Good morning, my dear. Today I have come in front of you to clear doubts of some of the students who have commented in my comment box of YouTube. So they have commented on the topic of circle, which yet I have not delivered, but still it's my duty to clear their doubts. They are from different school and from CBSE syllabus. So they have a doubt in circle. So let us clear their doubt. So the topic will be circle, and the very first theorem they had a doubt, that is the tangent at any point of a circle is perpendicular to the radius through the point of contact. So before going to this theorem, I would like to explain what is tangent. So you must be knowing, suppose this is a circle with center O. Now any point which lies on the circle, let us say any point which lies on the circle. So this is the point, suppose let us say X. So X is a point on the circle through which a line passes. That means if this is the line L, L touches the circle at only one point. That means it intersects the circle at only one point. Such line which touches the circle at only one point is said to be tangent line. Suppose if this line would have been in this way, that means it is intersecting the circle in 2 points. Let us say this point A and point B. Then this line, we won't be saying that this is a tangent line. This becomes then secant line. So, and this becomes tangent. So what is the difference between secant and tangent? The main difference is that a line which intersects the circle at 2 points is said to be a secant, and the line which just touches the point of the circle is said to be a tangent line. Now let's go to the theorem. So the theorem was the tangent at any point of a circle is perpendicular to the radius through the point of contact. Let us draw a circle here. Center be O, and let Px be any point on the circle, and let the line L be tangent. So this is given. Now on construction, now we have to construct. On construction, if the question comes in board exam, so you have to write in this way. This was given. This is on construction. You have to join OX. Join OX. Now let first you write here join OX and let Y be any point on the tangent apart from point X. So let us take what we have written. We have to take a point Y on any point. Let us assume the point Y lies over here. So now join OY. You have to mention here join OY. Now my dear, we can see what we have constructed. We have joined OX, we have where X lies on the tangent and also Y lies on the tangent. Here x lies on the tangent as well as on the circle, and we have joined OY. Now the intersection of OY with the circle BZ. Suppose this point be Z. So write it over here. Join OY and the intersection of line segment OY and the circle BZ. So let this point, the intersection of OY with the circle BZ. So this be the point of intersection. We write here BZ. Now solution. From here we can see that OY can be written as OZ plus ZY. Again, OZ and OX are same. OZ and OX are same because OZ is the radius of the circle, OX is also the radius of the circle. So instead of OZ, we can write OX is equal to OX plus ZY. Let me repeat again, since OZ is the radius. Now another doubt one more student have asked me. He is from Narayana School, Barashat. So he asked me how to prove this type of theorem. Let us read out the theorem. The theorem is the length of tangents drawn from an external point to a circle are equal. It's an important theorem. It's a very important theorem. And the basic knowledge of this theorem to prove is the simple basic knowledge of 7th standard. That is, we have to prove we have to know the rule of congruency. So let's find it out how to prove. First, let us draw a circle. Suppose this is a circle with center O, and let x be any point. See here, x is the external point. Here they have written an external point. So x is an external point. From this external point, you have to draw two tangents. So we can draw two tangents. Let us suppose this tangent is touching at y point and this tangent is touching at z point. What we have to prove from this is, we have to prove xy is equals to xz. This is what we have to prove, because the length of the tangent, so xy is the length of this tangent and xz is the length of this tangent. So the length of the tangents drawn from the point x are xy and xz, and this xy and xz we have to prove. So first you have to write to prove xy is equal to xz. Next, what you have to do is you have to construct. Now what is in construct? You have to join OY with dotted lines, you have to join OZ with dotted lines, and you have to join XO with dotted lines. Don't put any straight line from here. The dotted construction is always done with the help of dotted lines. Now one thing we can see from here, OY is equals to OZ. Why? The reason is they are the same radius of the same circle. Number two, we also know that this is 90 degree. Just before only we have read that the tangent makes 90 degree. This is also 90 degree. So the next statement what you are going to write is construction. So now we are going to write the construction. Here what you are going to write? Join OX. You have to join OX with dotted lines, OZ and OY. Here OY and OZ are equal. The reason is as they are radius of the same circle. Okay, now let us prove. Now here from this diagram, the diagram I have done in very short. Now from the diagram you can see that XOY is a triangle as well as XOZ is a triangle. So make a chart like this, statement, reason. Write down the names of the two triangles, triangle XOY and triangle XOZ. From this two triangle, we can see that OX is equal to OZ, number one. OX is equal to OZ. The reason is radius. Number two, XO is common for both the triangles. This XO is also for this triangle and this XO is also for this triangle. That means now you have to make the chart like this, statement, reason, and you have to make in statement you have to write that in the two triangles. The two triangles are XOY and the triangle XOZ. The very first one is, we can see that here OX, this OX is common side for this two. So we can write OX is equal to OX. The reason is common side. Next, OY is equal to OZ. OY is equal to OZ. Why? The reason is OY is radius and OZ is also radius. Radius of the circle. Radius of the circle. Next, angle XYO is equals to angle XZO. Angle XYO is equal to angle XZO is equal to 90 degree. Why? Because this is due to the theorem. You have to write here theorem. Don't write theorem like this. Don't give the theorem like this. You have to write the whole theorem. What was the whole theorem? The whole theorem was that whenever a tangent touches a circle, it makes 90 degree with the radius. That theorem you have to write it. So this is the statement number 1, statement 2, and this is the reason number 3. So from 1, 2, 3, that we can say by, see here, remember of RHS, right angled hypotenuse side. By that theorem, these two triangles are congruent. We can write it here, triangle XOY is congruent to triangle XOZ. Why? By RHS congruency. So now we have proved that these two triangles are congruent. Since the two triangles are congruent, therefore XY is equal to XZ. Therefore XY is equal to XZ. Why? CPCT. Congruent parts of corresponding triangles are always equal. Just write over here.